Hey guys, here's your solutions for the area under the curve video. For those of you that just kind of want to jump ahead and see if you got the right answers, they're the ones that are boxed. Otherwise, I will talk through each of the problems. So number one, poorly tuned Geo Metro accelerating from rest up to 28 meters per second in 20 seconds. What is the average acceleration of the car? That is just the slope of the line on your velocity time graph. So we have an initial velocity of 0, a final velocity of 28 meters per second, and a time of 20 seconds. So to find your acceleration, you're going to use velocity final equals acceleration times time plus your initial position. So since our initial velocity is 0, we have a final velocity equals acceleration times time. Divide your final velocity by time to get your acceleration, which is 1.4 meters per second. The second part, the distance it travels, well, that is the area under your curve. And now we have a triangle, so our area for that curve is 1/2 base times height. So we take 1/2 times the base is 20 seconds times the velocity, which is a height of 28 meters per second, to get a total distance of 280 meters. Number two, we start with a car traveling 30 meters per second, and after 6 seconds it's traveling 14 meters per second. Finding the average acceleration, that again is your final velocity equals acceleration times time plus your initial velocity. Here we actually have an initial velocity, so we will rewrite the equation as final velocity minus initial velocity divided by your time to get the acceleration. So here we have a final velocity of 14 meters per second, subtract that from 30 meters per second over 6 seconds. So we get negative 16 over 6, which works out to be negative 2.66 meters per second per second. And the negative makes sense because the slope of the line is negative. We're moving at a positive velocity but slowing down. So if our velocity is positive and decreasing, acceleration must be negative. How far does it travel? That's the area under the curve. So here we have a triangle and a rectangle. We need to find the area of both and add it up. So for the triangle, we have 1/2 times our base of 6 seconds times our height of 16 meters per second for a total of 48 meters in the triangle. For the rectangle, we have a height of 14 meters per second and a base of 6 seconds for a total of 84 meters. Add those two together and we get 132 meters for the total distance. A bear spies some honey and takes off from rest, accelerating at a rate of 2 meters per second per second. The honey is 16 meters away, so that will be the area under the curve. How fast will it be going when it reaches the treat? So we know that we have an initial velocity of 0 and that each second our velocity changes 2 meters per second. So that means that after 1 second, we're going 2 meters per second. At 2 seconds, we're going 4 meters per second. At 6 seconds, we're going, at 3 seconds, we're going 6 meters per second. 4 seconds, we're going 8 meters per second, etc., etc. So the area under the curve will be 16 meters. If that is 16 meters, that means that 1/2 times our base times our height has to be 16. So that means that some way half of our time multiplied by our velocity must be 16. So for that to happen, we need a velocity of 8 meters per second at 4 seconds, because that equals 32 when you multiply it together. Divide that by 2 and we get 8 meters per second, and that also works out to have an area of 16 meters under the curve. Number 4, bus moving at negative 20 meters per second initially, slows at a rate of 4 meters per second each second. How long does it take to stop, and how far does the bus travel while braking? So we have an initial velocity of negative 20, and it slows to a stop, which means that it's going to have a velocity of 0 at the end. So we want to know how long it takes it to stop if we have a negative initial velocity. Our final velocity is 0. We know our acceleration, so we can set up our equation of v final equals acceleration times time plus the initial velocity. But here we see that we have 0 for our initial velocity, 4 meters per second for acceleration. Then we have to subtract 20 because that is the initial velocity. So since it all equals 0, we can add that initial velocity over to the left. So then we have 20 meters per second will equal 4 meters per second times time. Divide each side by 4. We get that it is 5 seconds. And we know that because it is slowing down, that as it's coming to a stop, we have a negative velocity, and if that's coming to a stop, that slope of the line needs to take that velocity towards 0. That's why we have a positive slope there. Now finding the area under the curve at 5 seconds and negative 20 meters per second is the height. Our height is negative 20 here. Multiply that by 1/2 and we get a total distance traveled of negative 50 meters, which is also our displacement in this case. Number 5, physics student skiing downhill, accelerating at a rate of 2 meters per second squared. So this means that the slope of this line is 2. It takes her 15 seconds to reach the bottom. What is the length of the slope? So the length of the slope is going to be the area under the curve. We know that she has an initial velocity of 0, and so we're going to have to find what her final velocity is, so then we can find the height of the curve that we're going to need to find the area under. So her initial velocity is 0, so we can get rid of that. So we end up having her final velocity equals the acceleration times time. It takes her 15 seconds, and she accelerates at a rate of 2 meters per second. Multiply those together to get a final velocity of 30 meters per second. The area of a triangle is 1/2 base times height. So we have 1/2 times 15 seconds times 30 meters per second for a total distance. The length of the slope is 225 meters. Number 6, the dog will run uniformly with an initial speed of 5 meters per second for 8 seconds. So for 8 seconds he runs at a constant velocity at 5 meters per second. And then he begins to accelerate, so he increases to 10 meters per second in 5 seconds. So what is his acceleration during the second part? During his acceleration, well, he ends at 10 meters per second and he starts at 5. So to find what his acceleration is, we need to do his final velocity minus the initial, then divide that by the amount of time that it takes. So we have 10 meters per second minus 5 meters per second. Then divide that by the 5 seconds that it occurs over to get 1 meter per second for his acceleration. So now we want to know how long the driveway is. So we're going to have 3 shapes to add up here, but we can really break it down into 2. We have one long rectangle for the 5 meter per second line, which goes all the way out to 13 seconds. So when we multiply our base times our height, we get 5 meters per second times 13 seconds, and we will have 65 meters. And then for that little triangle, again, that will be a triangle, so we have 1/2 base times height. We have 1/2 times a base of 5 seconds, because 13 minus 8 is 5, times 5 meters per second, because our height is 10 minus 5, for 12.5 meters in the triangle, and a total length of the driveway of 77.5 meters. Number 7, we have a softball hit straight into the air with an initial velocity of 40 meters per second, reaches its peak height at 4 seconds, and then it takes 4 seconds to come back down to the ground, its initial position, for a total flight time of 8 seconds. What is the softball's acceleration? Well, this ball is hit into the air, so we know because of lab that the acceleration due to gravity is negative 10 meters per second per second. So that is the acceleration of the softball. The second part, the total distance traveled by the ball. So we have 2 areas under the curve to solve for on our velocity time graph. And our velocity time graph has the shape that it does because when it reaches its peak height after 4 seconds, it will have a velocity of 0 for 1 instant in time. And the slope of this line is negative 10. It's negative 10 because that is the rate at which the object is being pulled back down to Earth. So as it moves up, 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 so after 1 second, the object's moving 30 meters per second. They counteract each other here. And then after 4 seconds, the speed begins to increase in the negative direction. And because it's moving in the negative direction and acceleration is negative, that's why those velocities are increasing. So we have two areas under the curve defined. We have the first one is 1/2 base times height, the height of 40 meters per second in a time of 4 seconds for 80 meters. And the second triangle with a height of negative 40 meters in 4 seconds, again, multiply that by 1/2. Each of those, so the top one is positive 80, and the one below, the one with the negative velocity, is negative 80 meters. But since we're talking total distance, we can make that positive, so it has traveled 160 meters. The total displacement, because it starts and stops at the same spot, will be 0 meters. And finally, number 8, car whose initial speed is 30 meters per second slows to 10 meters per second in 5 seconds. What is the acceleration? That we just want the slope. So to find the acceleration, we take v final minus v initial divided by the time. We know all of those values. Initial velocity of 30 meters per second, final velocity of 10 meters per second, and the amount of time is 5 seconds for a total acceleration of 4 meters per second per second. So now I want to determine the distance it travels between 2 seconds and 3 seconds. So if we look at 2 to 3 seconds, at 2 seconds, the car will be traveling 22 meters per second, and we know this because at 1 second, so it starts at a time of 0, it's going 30. After 1 second, it will be at 26 meters per second. Oh, and that is actually a negative. Yeah, that is actually a negative acceleration. I realize that I just did that wrong. See, it's my mistake. There it is, 10 meters per second minus 30, so we have a slope of negative 4. So at 2 seconds, it will be traveling 22 meters per second. Go 1 more second, and we'll have a velocity of 18 meters per second. So for this triangle, so this area under that curve, from 2 to 3 seconds, the triangle will have a height of 4 meters per second, and it will be 1 second worth of motion. So 1/2 times 1 times 4 gives us 2 meters. And then that rectangle will have a base of 1 meter, or of 1 second, I'm sorry, and the height will be 18 meters per second for a total distance there of 18 meters. Add the two distances together and you get 20 meters is how far that car moves in 1 second. There's your solutions for the area under the curve.